Hi, I'm Brian Amrine with Value Driven Analytics, and in today's training session, I'm going to show you how to perform a subquery and a common table expression, or CTE, in SQL. What's a subquery? Is that like a question from a sailor? Is that like when the sandwich shop asks if you want mayo? A subquery is just a SQL query within another SQL query. And a common table expression, or CTE, is a very similar but just slightly different concept. I'll show you how to do both of these using SQL within Python, but these SQL concepts can be applied in any SQL platform. Now let's head over to our Jupyter Notebook. Here we are in our Jupyter Notebook, where I'm going to show you how to perform both a subquery and a CTE. Now you don't need to do this, but if you want to follow along and run the code alongside of me, feel free to download Anaconda if you haven't already. That'll download the Python executor. It'll download some common Python packages, including the Pandas package that we'll use today. And it will also download the Jupyter Notebook interface. Now I've got a training, Intro to Python training. You'll find the link in the description that'll walk you through how to download that, just the very first part of that. And if you did want to learn more about Python data manipulation, feel free to continue going through that training session. And of course, we'll be using SQL within Python today. So if you want to learn more about SQL, we also have an Intro to SQL video too. But if you already know a little bit of SQL and you want to learn how to do subqueries and CTEs, feel free to just follow along. You don't need to download Jupyter. You can just watch this video and that'll be just fine. You know, these two tools, Python and SQL, which is what we're going to look at today, go really well together. SQL is great for basic data manipulation, selecting data from a certain table, creating calculated columns, grouping and aggregating. It makes that really easy, and it's very flexible for joining tables together, one of the most flexible tools for doing that. Python, of course, you can do that as well, especially using the Pandas package, which we'll use today. But Python, in addition, on top of SQL, can also build data science models and perform looping for advanced automation use cases. So these tools go really well together. And as we'll see today, we're actually going to write SQL code in Python using the Pandas QL package. So let's go ahead and get started. One more thing, if you want to follow along, you'll also need to download the Subqueries and CTEs.ipynb Jupyter Notebook from the Value Driven Analytics website. And you can find the link to that in the description as well. So you'll need to launch Jupyter and then open that particular Jupyter Notebook that you'll download from the website. And the Intro to Python training video walks through how to do that. But again, you don't need to. So our subquery use case today is going to have two tables that are manually being created here using the Pandas library, one of the most popular packages in Python for data manipulation. We're just manually creating those, creating a sales data set that just has a few rows and a cost data set. And what we'll want to do is join these together. Let's take a look at our data set here. We essentially have one row per transaction item. So on some transaction, there was red, small, and these are t-shirts, red, small t-shirts, and there were two that were ordered on that line item. And then in another order, or maybe the same order, different line item, we don't have an order ID here. We won't use that in this case. But there's a black, small, and there were 5 of those that were ordered. And here's another red, small row as well, like we had before, but in this case, for this line item, there was only 1 ordered. Perhaps it was a different order. And then we had have a white large, and there were 4 of those ordered. So you get the idea. It's kind of a list of transaction items. Then in another table, we have a cost table. And this isn't necessarily a cost at the transaction level. That's probably how you'd want to bring it in. But let's say in this case, for some reason, the cost isn't included in our sales table. But we do have another table that records perhaps over time what the cost has been. And in this case, it's kind of a silly example, but the cost just depends on the color. And so what you'll notice here is we just have 1 row for white t-shirts and black t-shirts. We have 2 rows for the red t-shirt. One was $10 and one was $15. Again, perhaps we'd have another column with a timestamp here. maybe what happened, we're not sure, but we're kind of exploring the data set. Maybe what happened for this red t-shirt is at one point it was $10 and another time it was $15. So there's duplicates on color here is what we're noticing. And of course, the first thing you'd want to check before you join two tables together is whether there's a duplicate on whatever you're joining on. And in this case, we're going to join on color. It's very obvious that there is a duplicate for red. It's in the table twice. And so you want to be very careful when you merge tables together when that's the case. So before I even try to write a SQL query to join the two tables together, I would write a SQL query to check for duplicates. Let me just show you how to do that very briefly. First thing you're going to need to do if you've never used Pandas QL within Python before, you can click plus here and you'll just need to install it one time. You only need to install a package in Python one time and then you'll never need to do that again as long as you're using that distribution of Python. And so you can basically take this code that's going to install it from the pip repository and it's going to install Pandas QL. So you go ahead and you can run that, click into the cell, and click run if you need to. This is already installed for me, but I just wanted to point that out. What we're going to do here, we do always need to import packages that we use at least once within each Jupyter session. So we'll need to import Pandas QL. It's going to allow us to write SQL against a Pandas data frame to create another Pandas data frame. Again, these concepts that we're talking about apply in any SQL platform, Snowflake, SQL Server, whatever you're using, but in this case we're using Pandas QL within Python to write some SQL code. So we have some standard syntax here. This is going to be the name of the data frame that it creates, and then within these triple quotes is just a regular SQL query. It's technically using SQLite syntax here, but the concept of a CTE and a subquery, pretty much the same across all your different versions of SQL out there. All right, so the first thing that I'm going to do, if I'm going to be joining the cost table to the sales table and if I'm going to be joining on color, I need to make sure that color is one row, that the cost table is one row per color. So the way to do that is to count star to get the just total number of rows. We'll call that total rows. And then we need to count distinct whatever we're joining on, whatever we think the table should be one row per. In this case, it's the color column. And that'll give us, we'll call it distinct color values. Let's go ahead and run that, and then I'll have it display df. And so right away we would see if we did our homework and check for this, which you always should when you're joining tables together, is the table we're about to join in on color, the cost table, it is not one row per color. There's 4 rows in the table and there's only 3 unique color values. We would know that there's an issue here. And then you probably take a look at what those duplicates are. Again, we could see, since it's only 4 rows, it's very easy here to see that the red color's in there twice. Well, in these situations, again, perhaps the price got updated. What we want to do, let's say we dug into it and we figured out exactly how we want to handle this. What we'd want to do is take the minimum and the maximum price and bring that in for a row. If we did not do that, if we just ignored the fact that there were duplicates here and we joined in the cost table on sales on color, like I did here, watch what happens to the result. We actually end up with 6 rows now. We had 4 rows originally. What's happened is the 2 red rows, the red small with a quantity of 2 and the red small with a quantity of 1 from our original sales table, they've been duplicated. There's been a row created in the output table here of our SQL query for the red row that had a cost of 10 and a red row that had the cost of 15. And likewise with the other red small quantity of 1 row. A duplicate's been created, one with a cost of 10 and one with a cost of 15. So it's created 2 extra duplicate rows. Nothing throws off an analysis like duplicates. This is a really good use case for a subquery. Of course, if one option would be to create this table, this cost table that ends up eventually being one row per color after we do some aggregation and create that as a separate table and then join it to our query. But it can be so much simpler than that. You could just write that SQL query within your SQL query. So that's how we'll handle it down here. In this case, instead of just joining directly to the cost table like we did before, we're going to write a SQL query within a SQL query. And what you'll notice about this is we start our SQL query with parentheses. So I have a left join here, just like I did above, where it created duplicates. But now instead of just listing out the table there, we have a query there instead. So if we were to, I'll go ahead and just start right here. Here's was our original that had some duplicates. What we want to do is do some aggregation before we join it in. We need to get this cost table. We need to turn it into a table that's one row per color. So what we'll do here is delete cost. Just go to the next line. I usually go to the next line for a subquery. So I'll list the left join still. But what we're going to do is put a query within these parentheses. And a very good formatting technique, this is pretty common when you're dealing with subqueries, is to use some indentation. So I will start my query within a query with an indent, and I'll say select. I'm going to select ultimately the color, and I'm going to do some aggregation here. So remember we said, well, okay, there could be multiple rows like what we saw for the red t-shirt. Maybe the price changed. So perhaps what we actually want to bring into our final table here, we land on bringing in perhaps the max cost. What's the highest it's ever been? Max cost. And then also the min cost as well. And of course, this is just a regular query. So all the rules that apply to our outer, by the way, this main query that we started with is called the outer query. A subquery is sometimes referred to an inner query. You can see it's indented a little further. Maybe that's a way to remember it. Same rules apply to creating that query as the outer query. So we'll say from statement, from the, let's see, we called it the cost table. And I'm going to group by color. So this grouping is going to get it to one row per color. Now, if you were in doubt of that for some reason, you could obviously test that and count star and count distinct color from the result of this. But when you group, it gets it to one row per whatever you're grouping by. So this will solve that problem for us. And now I believe this will run okay. Let's check out the results. Looks like I might have forgotten a comma here. Yep. Run that again. Okay. Wow, this is good. What I'm noticing first is it is only 4 rows. And remember, our sales table was just 4 rows. And so now for the red t-shirt, we see it shows a min cost of 10 and a max of 15 for both of our red t-shirt rows. The other rows, the black and white t-shirt, in our cost table only had 1 row, and so it ends up being a min cost and max cost of 15 for the black t-shirt, 12 for the white t-shirt, and then the red t-shirt shows the min and the max of 15 now. Really neat. So this is just one use case for using a subquery. Now, a couple of other things I wanted to mention about a subquery. So I'd written this same query down here. Your subquery, you can have multiple subqueries within a query. And so we could have another inner query of sorts here. Let's say we had another table that we needed to do some manipulation against before we wanted to join it in. We could perhaps have another left join. Maybe this is a different table. Maybe it's not the cost, but maybe it's a margin table or something like that. And so we need to do some aggregation on that. Perhaps there's duplicates in that table as well. You can have multiple subqueries within a query. Another thing you can do, this will be kind of a silly example, but I'll just select star from this. That would be a query within a query within a query. You could do that too. Now that can get a little hard to view sometimes. I'll show you one formatting technique that I would recommend if you are going to have a query within a query within a query. At that point, you may want to use a common table expression, which we'll go over just shortly. But instead of this, perhaps this was going to be a query too. So in our from statement, we would have parentheses and then a close parentheses as well. Now another thing, at least in some SQL platforms, you have to give your SQL query an alias. So you may think, let me just do select star, which of course, if you're just selecting star, you might as well refer to the table. Sometimes when you have too many subqueries, that can really slow down your performance. Having one or two most likely won't be an issue, but if you do run into performance issues, you may get to a point where you just create a temporary table and join it in, and that might give you some better query performance. But if you're just doing a handful of subqueries, usually it's not an issue. So I'm just showing this to illustrate the principle of now we have a, we'll probably put that on the same line, a query within this query within the main query, right? So this would be our inner query, so to speak. Again, just a silly case where we're selecting star from cost. If that's all we're doing, we just have a from cost. But I just wanted to illustrate this principle. Now this, in some platforms, will error out because it wants you to put an alias for every subquery in your query. So notice below I just gave it the name of B here. I would need to give this an alias as well. So just after that closed parentheses, I could use the same one. It would make a difference here. I just need to give that subquery an alias, even if I'm not joining it with anything else like I would be here. You've got to have that. So I just wanted to point out that you can have subqueries within subqueries, but just be careful. If it gets slow, you may or may not want to save it as a permanent table, and you could drop it after that. All right, so that would work. Let's go back to maybe our original subquery here. I want to show you how you could set this up as a common table expression. It's a very similar concept. So I'm going to take the query we came up with here, paste it down here. Now the concept here is going to be creating a query within a query, but creating that query at the top of your code and then building a query on the results of that. And you can do this as many layers as well. If a subquery is almost like a horizontal query within a query, we kind of built it out more and more. I kind of think about a CTE or a common table expression, just more of a vertical format. You've got a query and you're going to build a result based on that query and a bit result based on that query. As many as you want, but your CTE is going to start out with the keyword with, and then you'll give that CTE that's being created in this step, you'll give it a name. So with, we'll use the same name here. Should probably give it more intuitive names, but I'll just use B here like we did before. With B, that's the name. It can be any name as long as you consistently refer to B later on. As, that's a keyword here. And then we're going to use open and close parentheses, just like we did with the subquery. And then I'll write my SQL query within this. I'd also recommend indenting the query within your CTE too. So I'm just going to illustrate the concept, again, we're trying to dedupe this cost table. We're trying to group by color before we join it into sales so we don't end up with duplicates. And our final result, I'll paste that in here. And so we've got our query. And now, instead of needing to have the query here within the main query, it's defined up here. It's defined as B. And so down here, all we're doing is just referring to B. Whatever name we gave it up here, we're saying left join in that B that's been created as a CTE above, join in on color. So what we've kind of done in some cases, if your query gets really complex, this is kind of our main query here, but before we get to our main final query, this is the query that will ultimately determine what results are outputted with the query. In this case, they're being put into an object called df. This is kind of the final query, but there's some queries ahead of time that are being ran. It's almost like creating a temporary table, so to speak. And And that allows your final query to be much simpler, right? With the subquery, everything was being defined in one query, which in some ways is nice, but again, it can get really out of hand in some cases, especially if you have queries within a query, or queries within a query within a query, or just multiple subqueries. You may prefer to do all of any pre-querying that needs to be done, like we're doing here, grouping that needs to be done, deduping that needs to be done. You may prefer to do that in steps above, and then at the end, you just have all your joins, and it's just a single line join statement. So before we showed how you might have another one. Let's just do an example of what that would look like. If you did want to bring in, say, you needed to write multiple queries before you ran your main query, you would, we'll call it C here. What that looks like, you only list width one time. But the part that you would repeat is basically the rest of this. And these would be separated by commas, and there would be no comma after your last CTE. So notice with just one CTE, there's no comma after the closed parentheses. And then if you had multiple, you would separate them with a comma, but then the last one, similar to when you just have one, would not have a comma, and then you just have your main select statement at the very end. So here, let's say we have, just need to create another one, similar to when we had multiple subqueries. Let's just call this margin. Of course, we'd have to update other things here, but let's say this is another table that needs to be deduped. We're going to join it as well, and so we're also creating this table C as well before we join everything together. And now you can see at the bottom here, we would just refer to B when we wanted to join in table B, coming from the cost table, and table C when we wanted the result of this, pulling from the margin table. Simple as that. So that would be your multiple CTE use case. And let's just say you needed to create 3 tables, right? Notice how there's a comma between each CTE that's being created here, again, except for the last one. And then after that last one would be your main select statement that's going to determine what's actually outputted by your query. Well, I'll just go ahead and run the simple case here that we started with. So you can see what the output looks like, and it should look exactly like what we had before with the subquery example. We've just written it a different way. So I'll display the data frame. That's what, in this case, we're using Pandas QL. It's creating a data frame called DF. I think that looks good. Look at that, 4 rows. Min cost, max cost, exactly like our subquery example. We've just defined the query within a query at the top of the code instead of at the bottom. So you'll probably find your own style. Again, my general recommendation would be a couple things. When you have too many subqueries, when you have a lot of subqueries in your main query, when you have queries within a query within a query, it might make sense to just create a few queries at the top and then have a really simple final query. And then if you needed to say, well, how is that B created? How is that table B created? You just go and find where it's defined at the top of your query to CTE. I think a lot of people prefer that. They don't want just one big select statement with really complex joins. So if the CTE gets out of hand, it can be a little more readable, or the subqueries get out of hand, it can be more readable to have your CTEs just at the top where you're defining each table. Another reason to use a CTE in particular is if, let's say we do this data manipulation to aggregate at the color level, one row, get our data set 1 row per color. Maybe there's some other step that we need to do prior to our final query. Just something that needs to be done before we even join table B here. So what you could do in this case, again, this would be kind of a silly example like we did for our query within a query. Maybe that, in this case, we'll just do C as, and then our open parentheses. And in this case, what we'll do is we'll do select. Again, no reason to really do this, but it just shows the concept. Select star from B. So here we're creating B and the first CTE, and then on our second CTE, where we can reference that table. And so if that table is going to be used multiple times, that subquery is going to be used multiple times, rather than repeating your subquery so many times, if you write it as a CTE, you only need to write that once, and then you can refer to it in another CTE, or even if you needed to, for some reason, join that CTE in multiple times, in a subquery example, you would need to write out your subquery. You'd have to copy and paste it multiple times in your join statement. That's not ideal. You don't want to repeat your code more than necessary, and it's not necessary in this case. You just define this table, this subquery B here as a CTE, and then you can just refer to B later on, rather than having, two subqueries with that entire statement copied and pasted. So if you're going to be needing that subquery multiple times in your main query, that's a good reason. And then in this case, let's say we had created this CTEB, and then we wanted to do some further data manipulation. Again, in this case, it's really just simple. But we're creating C based on table B, so we can refer to B in another subquery. And now what we'll do in our left join here, we can refer to table C. Just a silly example. Of course, you wouldn't create just a table C to select star from B, but if you need to do some further data manipulation before joining in the final result for some reason, CTEs are another great way to do that. If you're going to be using that subquery multiple times for one reason or another, maybe you need to build another table on top of that, like we did with table C here, or you're going to need to be joining it into the final query multiple times, perhaps on a different key each time. Both of those are good reasons to, instead of just copying and pasting subqueries or ending up with a really large one select statement, just set it up as a CTE. But if it's just our original use case here, we'll scroll back up to that, you could write it either way, but this is not very complex. This is one CTE. It's all in one select statement, which is kind of nice in some ways. And so if it was this simple where we just have one CTE or one query within a query, I'm going to write it as a subquery, just like we did here. So hopefully that's helpful, some direction as you think about whether to write a subquery or a CTE when you need to write a query within a query. I hope you like this overview of SQL queries within SQL queries through subqueries and CTEs. And if you did, I hope you'll consider liking this video formally. If you'd like to see more SQL tutorials like this one, and trainings on so many other analytics and data science concepts, please consider subscribing to our Value-Driven Analytics channel. And if you have any queries about queries within queries, consider leaving a comment and I'll do my best to answer them. And now you're free to write a CTE, or even 3. What jubilee? In a Value-Driven Analytics T? Wait, that's me.